We're now going to explore some effects of transformations, and the very first one is the transformation of a function when a modulus is applied to it, to fx. So what we see over here in this example is when we modulus a fx function, it would naturally just mean that a lot of its whatever x coordinate used to give, instead of providing an output that is of a negative value, it would now be converted into a positive value. So this graphically also means that we are doing a reflection of this graph, the negative part of it, about the x-axis. So if I have a quadratic graph such as this, what happens is every part of this negative portion of the function is going to be reflected about the x-axis, and so the final graph that we see over here in green would be the transformed graph when we apply a modulus to it. What would be the effect then if we are to apply a modulus to only the x values? So what this really also means is that we are only keeping all the positive x values, because now there are no inputs such that the x values are going to be negative at all. So because of that, we first keep the positive part of the graph, and since also the output of whether you substitute in a negative, if whether x ends up as a negative 2 input, it still gives rise to a positive input. So both sides, for example, is going to give you the same output, whether you subbed in negative, whether you subbed in 2 or negative 2, the output is going to be the same. So what this also means is that we are going to do a reflection about the y-axis. So this graph, after its transformation, it's going to be symmetrical about the y-axis, and this is the way we do a transformation for x modulus. Okay, an example here. So if we are given this graph that's sketched in dotted lines, and we are asked to do an fx modulus, what happens is we are going to be keeping all the y values that's positive, and whatever part of it that is negative y, I am going to do a reflection about the x-axis. And so similarly this part here, so the part that is drawn in solid will be our modulus fx transformed graph. If I do a transformation now on the same fx graph, the dotted graph that's given to us, and instead I'm going to do a modulus x transformation. So if we recall, the very first step is to just keep all the positive x values. So I'm going to keep all the positive x values and discard all the negative x values. I have to remember that to do a symmetry about the y-axis, so I need to keep the point 3 and 0 and have it reflected and mirror it about the y-axis. So there's a new coordinate and a new turning point over here, which I do not know what it is. So let me do an estimation and do a reflection. So you could draw it a little bit better than this, of course. So this would be my y equals to f modulus x transformation.